I'm having one of those days when screen recording software just doesn't want to cooperate with image viewing software or web browsers or anything else. So, we do this the really horrible way. Irish Demon posted a video from a beach in Perth, Australia, down, oh good, I can't see the cursor while I'm filming, there it is, down here, Perth, Australia, facing in this direction towards Paris, France, up here, and asked, why can't I see the Eiffel Tower? I think he knows. He's not stupid. He knows perfectly well why not. But I thought I'd answer anyway. If anyone's bothered by this curvature, by the way, this line being curved one way there and then straight across here and curved the other way here, that's just an artifact of this being a projection. If you'd like that line to be straight, that's easy to achieve, we use a different projection. Yes, and if I hold the camera in just the right place, it all fits on the screen. There we go. You can see the line leaves the coast at the same angle, passes just southwest of Sri Lanka and India, across the Indian Ocean, into the access from the Arabian Sea towards the Straits of Hormuz, across Iran, across northeast Iraq, across Turkey, the Black Sea, southeastern Europe, and up to Paris in France. This ugly mess here is what's left of England. Out here we have Japan, and down here is of course Namibia. And on the keyboard somewhere there is a left arrow, which lets me go back to the previous image, where you can see the same thing, leaving Perth at that angle, on that bearing, southwest of Sri Lanka and India, across the Arabian Sea, up the access towards the Straits of Hormuz, across Iran, Iraq, Turkey, the Black Sea, southeast Europe, and into France, ending at Paris. And out here, this is Japan, and this down here is Namibia. It appears slightly different because it's a different projection. No cause for alarm. So, to answer the question of why he can't see this thing from Perth. This is a photograph I grabbed, and I forgot to grab attribution for it. I think it was on the Independent's website, 7 best ways to experience Paris or something like that. A quick search reveals this thing is 300 metres high, which I think means to here, and 324 metres to the tip, which is presumably this spot here. From what appears to be the centre of the base down here to the tip is 995 pixels, making this 3 pixels per metre. Across the wide part here it is 135 pixels, making it 44 metres wide. Up here it is narrower, so going to be less visible, and down here it has a hole in it. And bear in mind, if you're looking for a silhouette against a bright background, you are limited by light coming through holes in it or coming past the sides of it, blurring together. This is the Rayleigh limit, which I have already covered in another video. If you cannot distinguish the light here from the light here, you can't see this bit in between them. If the light here and the light here blur together, you won't be able to see this bit between them. Having light coming through it doesn't help, so I think this bit, or this deck here, would be the most visible. And to work out the actual limit on that, here we go. A whole lot of unnecessary maths. Take the width and divide it by the distance, and then halve that to get the ratio of half the width to the distance. Take the arctan to get the angle subtended by half the width at that distance. Double it to get the angular width of the whole thing, and take the sine of that, and you get right back to the ratio of the width to the distance, because these are small angles, and for small angles sine and tangent are pretty much the same thing as the angle in radians. Proportional to the angle, in other words. So all of that was wasted effort. Because the Rayleigh criterion uses 1.22 times the zinth angle, we divide by 1.22, and then we divide our wavelength This is the sensitivity peak of the blue sensitive cones in your eyes. By that number, that fraction of the sine of the angular size of the thing, to get this, 0.17 meters, also known as 6.7 inches. That is the minimum angular size, sorry, that is the minimum diameter, angular size, honestly, the minimum diameter of an aperture required to take a picture in which that thing there can be distinguished as a dark patch in between this bright bit and this bright bit. As Irish Demon's video is posted in portrait format rather than landscape, I assume it was taken with a smartphone. Smartphones generally do not have 7-inch apertures, for what I would hope are really obvious reasons. But that, of course, is daylight, and if he was standing in daylight in Perth when he made his video, it was probably dark in Paris. Il était fait, et illuminé dans la nuit. Alors, pourquoi il n'a pas vu cette heure? Well, this was in the way. Along that line of sight, pretty much on the border between Iran and Iraq, is this thing. This is a 2,200 meter contour line. This is a 2,000 meter contour line. You can see the line of sight, well, line of flight more like, crosses this 2,000 meter contour line. If Paris was 2,000 meters above sea level, it would be a ski resort. Of course, this brings up the interesting question. If that thing is so much bigger and so much wider than Le Tour Eiffel, why couldn't he see that? Or, even better, why couldn't he see this big bugger? I mean, that's pretty huge. That's Mont Blanc. And this scary looking thing here, Lac du Midi. Yeah, that's actually a building on top of it. It's split in two. There is a bridge across the gap in the middle. And if you go up the cable car... Oh, there's the bridge. There. If you go up the cable car into this building and across this bridge into the tunnels here and turn left, you can come out onto this ridge and walk down it and off the far side to the left and ski down the glacier if you're a complete idiot. Of course, well, if you're not a complete idiot, you know the actual reason you can't see this thing from Perth. He was looking the wrong direction. Should have been looking down. That and the Eiffel Tower are on the far side of a planet.